We'll continue our review by solving a couple of quadratic equations, a rational equation, and a radical equation. So our first quadratic equation we are going to solve by completing the square. In order to complete the square, a has to be 1. So we have to divide every term by 3. So we get x squared plus 1/3 x minus 3 equals 0. Okay, so we've got a lead coefficient of 1. Now we'll move this c over and make room for a new c. So x squared plus 1/3 x blank for a new c equals 3. And whatever I add here on the left, I have to add on the right. Okay, now to find the new c, we take b, which is 1/3, divide it by 2, and square it. Okay, now I'm going to make this 2 into a 2 over 1, and to divide these, I can do this outer loop. That's 1. This inner loop makes 6, 2 times 3, and I square that. Okay, so 1/6 squared is 1 over 36, so plus 1 over 36. Okay. So I have now completed the square, so now it is time to factor and solve. Okay, now down here in this blank it does ask for our new c, and that is 1 over 36. Okay, so now to factor. Okay, I made a square trinomial, so I know it will factor into a binomial squared. Okay, so what multiplies to 1 over 36 and adds to 1 over 3? That's this number right here. B divided by 2 was 1/6. So x plus 1/6 squared is the factored form. Okay? Then 3 plus 1 over 36. Let's just use the calculator for that. 3 plus, and then I'll use the math key over to number, down to the bottom, get my fraction 1 over 36, and I get 109 over 36. Okay, so now I can get rid of this squared by doing a square root. So I get x plus 1/6 equals plus or minus the square root of 109 over 36. Okay, so then I will move this 1/6 right here. So x equals negative 1/6 plus or minus. Okay, 109, there are no square numbers that go into 109, so that's just going to stay the square root of 109. The square root of 36 is 6, so our final answer is negative 1/6 plus or minus square root of 109 over 6. Okay, so now, using the quadratic formula, x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so that's 2 plus or minus the square root of, so negative 2 squared, that's 4, minus 4 times 3 times 4, and that's negative 44. All over 6. Okay, so this negative 44, the square root of negative 44, that is the same as the square root of negative 1 times, and then the biggest square number that goes into 44 is 4, 11 times. Okay, so I have the square root of negative 1 times 4 times 11, so that's 2 plus or minus, square root of 4 is 2, the square root of negative 1 is I, times the square root of 11 all over 6. Okay, so now, is there a number that can be divided out of all three terms? And there is. That number is 2. So my simplified form here will be 1 plus or minus I times the square root of 11 all over 3. Or it could be split up as 1/3 plus or minus I times the square root of 11 over 3. So either of those two solutions is completely valid. Next, we will solve a rational equation. So first, I want to know the domain. What can n not equal? So if I make n 5, then I'll get a 0 denominator here, and I can't have that. If I make n 0, then I'll have a 0 denominator here, and I can't have that. So if I get a solution of 5 or 0, I'll have to throw that out. Okay, so to solve it, I'm going to distribute the factors of the denominators, which are n and n minus 5. Okay, so when I distribute here, n minus 5 cancels, so it's 2 times n. When I distribute here, n cancels, so it's 3 times n minus 5. So that's 3n minus 15. When I distribute here, n minus 5 cancels, so it's 4n times n, which is 4n squared. Okay, so now let's get everything on one side, and the n squared term is positive here on the right, so I'll move everything to the right, so I get 0 equals 4n squared minus 3n, actually that's 5n, 2n and 3n, so minus 5n, and then plus 15. Okay, now I have three options. I can factor, I can complete the square, or use the quadratic formula. Let's use the quadratic formula. So I get n equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so I have 5 plus or minus the square root of, so negative 5 squared, that's 25, minus 4 times 15, and that is negative 215, all over 8. Okay, now let's see if I can simplify this radical. So negative 215 under a square root, that's negative 1 times, and I know 5 goes in there. Let's see, 215 divided by 5, it goes in 43 times. And 43 is prime, 5 is prime. I'm not going to be able to simplify much, but I can get that negative 1 out of there. Okay, so I get n equals 5 plus or minus I times the square root of 215 over 8. Okay, now is there anything that goes into 5, 8, and 1? No. So that's my final answer, or I could write it as 5/8 plus or minus I times the square root of 215 over 8. So either of these versions of that solution is just fine. Okay, and neither of those are violating my domain where n can't be 0 or 5. Okay, so last up we will do a radical equation. I want to start with one radical per side, so I'll take this negative radical and move it to the right. So I get the square root of 6x plus 12 equals 1 plus the square root of 4x plus 9. Okay, now I will square both sides. So on the left side, I get 6x plus 12. On the right side, I got to remember a plus b squared is a squared plus 2ab plus b squared. Okay, so my first term squared is 1. Double the product. I have 1 times the radical. Doubled is 2 times the radical. And then this last term squared is 4x plus 9. Okay, now let's move everything but the radical term over to the other side. So I have 6x minus 4x, that's 2x. 12 minus 1 and 9, so that's 12 minus 10, so I've got 2 equals 2 times the square root of 4x plus 9. Okay, let's make this a little bit simpler. Let's divide both sides by 2. X plus 1 equals the square root of 4x plus 9. Now square both sides. Okay, so the first term squared, x squared. The product of these two is 1x, doubled is 2x. And the second term squared is 1. On the right side, square and square root cancel. Okay, now let's get everything on the same side where the x squared term is positive. So x squared, 2x minus 4x is minus 2x. Okay, and then 1 minus 9 is negative 8. And I think we can probably factor this. Multiplying to negative 8 and adding to negative 2, we could use negative 4 times 2, negative 4 plus 2. So we have x minus 4 times x plus 2 equals 0. So x is 4 and negative 2. Now before I decide that those are valid solutions, I need to check them. Okay, so I have the square root of 6 times 4 plus 12 minus the square root of 4 times 4 plus 9 should equal 1. Okay, so that's 24 plus 12 is 36. The square root of 36 is 6. 4 times 4 is 16, plus 9 is 25. The square root of 25 is 5. 6 minus 5 is 1. That checks out. Okay, now check the negative 2. So 6 times negative 2 plus 12 under a square root minus 4 times negative 2 plus 9 under square root equals 1. So that's negative 12 plus 12 is 0. Square root is 0. And then negative 8 plus 9 is 1. Square root is 1. 0 minus 1 equals 1. That is not true. So I cannot keep this solution. That is extraneous. So x equals 4 is my solution.